All right, section 2, Swyk 2. No, that's not some sort of bad-looking mushroom or nuclear bomb. It's my tree. I'm not an artist. Don't make fun of me. 170-foot redwood tree casts a shadow. I hope it does. Express the length of the shadow as a function of the angle of elevation. Oh, we need to talk about angle of elevation, angle of depression. Angle of elevation is always measured from the horizontal up. So that term right there, angle of elevation. So when you look straight out at something and you measure the angle up to the top of it, whether it's a tree or a flagpole or a building, that's called angle of elevation. Now, if you're standing up above something and you look out and you measure down, that's called angle of depression. The interesting thing is angle of elevation and angle of depression typically are equal to each other, depending on what we're talking about. For instance, if you were standing on the ground, that's you, by the way, looking up at me, yeah, you can see there's like one hair on my head, then the angle of elevation would be you looking up. But if I'm looking down, I'll have an angle of depression, and that angle of depression happens to equal your angle of elevation because those two lines are parallel lines, right? And we know that a transversal that cuts through parallel lines creates alternate interior angles. You thought you were going to get away from that phrase? No. So, angle of elevation, angle of depression. If we're dealing with the same person, same objects, they are the same. If we're talking different objects, one person's up on the second story, and one person's up in another building on the 10th story, and we're looking at different objects on the ground, there's going to be different angles of depression. But side note, okay. All right, in this particular case, we have an angle of elevation. We don't know what it is. We do know that the height of the tree is 170 feet. So you see I labeled the height 170. I labeled the angle with the Greek letter theta, in case that's confusing. Theta, that's what this is, theta. You'll see it in Greek sororities and fraternities when you go to college. Anyway, unless you take Greek class and you study the language, yeah, you see it there too. So in this case, they want me to find an equation that will identify x. Well, opposite, adjacent, that's tangent. So tangent of theta is 170 over x. Well, they want me to solve that equation for x. Okay, I can do that, right? Cross multiply. I get 170 over tangent theta. And that's what's going to go in that first blank. They've already got the x equals part. Now, for the next question, when theta is 35, plug in a 35 for theta. Sorry. And then you get 242.8 for the length of the shadow. And then 70 degrees, plug in 70 degrees, and you'll find out that the length of the shadow is much shorter, 61.9 feet. Always look to see what unit of measurement they're asking for, whether it's tenths or whole units. Next. Here they're asking you just angle of depression, angle of elevation, okay? So angle 9, which has been identified, they actually have it identified on the sheet with a line like that. Now, I don't like the way that they word this. This kind of is confusing to me, but okay, I'm going to go with it anyway. It's an angle of depression because it's being measured from the horizontal down, and it goes from angle A, I guess that's from A to C, right? From A to C. Starts at A, goes down to C. I don't know, that's kind of a weird way to say that. I mean, I was thinking they were going to say it's the sum of Thought they were going to list out like the sum of 8 and 9, you know, or something like that, but they didn't. So from A to C, and that's an angle of depression. If it was from C to A, that'd be an angle of elevation, right? Like number 6. Next. All right, so angle 5. Angle 5 is measuring up, so that's got to be an angle of elevation from Alfred to the top of the waterfall. Okay, now we're getting into non-right triangles, okay? And we're having to use something called the law of sines. Now, what is the requirement for the law of sines? You would have thought I would have written it on this question, but no, I wrote it on the other question. I don't know. So what is the requirement for using the law of sines? Well, let me zoom in on it. You must have a known angle and a known opposite side. Remember, this is for non-right triangles. If I've got a right triangle, I'm just hitting it with SOHCAHTOA. I'm not getting all fancy. Just, here's your requirement. Make sure you understand this and look for it in every question that you think or suspect might be a non-right triangle. So, do we know all the angles here in this particular triangle? We sure do, right? Because we know that all three add up to 180, so we can subtract 93 and 47 from 180. We find out that the remaining angle is 40. So remember, I just said that in order to use the law of sines, you must have a known angle and a known opposite side. Ding, 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 ding. We've got it right there. Known angle, known opposite side. So you might look at this at first and go, we don't have a known angle and a known opposite side. Au contraire, you have to figure it out. And that's an easy one to do. So, how do you do this law of sines? It's a proportion. It's easy. You'll get it. No problems. So you take the sine of the angle, in this case 40, divided by its opposite side, equals the sine of another angle divided by its opposite side. Since I'm looking for angle x, side x, I use the angle 93. Sine 93 over x. Sorry. Just cross multiply. That's all you have to do. Now you're going to notice what I wrote with the red arrows. And what I'm hoping that you realize is that you multiply these two and divide by the remaining one. So x is equal to 10 sine 93 over sine 40. Now, your calculator might put parentheses around the 93. Don't forget that parenthesis right there, because you will get the wrong answer if you don't put that there. Okay? So, hold on a second. I'm being invaded. Okay, so we cross multiplied. We end up with 15.5 to the nearest tenth. So each one of these new situations is going to be the law of sines, and I am going to look for that pair, right? The known angle and opposite side. When I find it, I set up my equation. Sine 117 over 18 equals sine x over 12, because that's the other pair. This one's different, though, because I'm trying to find an angle measurement. So when you do the cross multiplying, right, 12 times the sine of 117 divided by 18, you end up with this decimal point 594. Don't panic. That's not the angle. You still have to invert the sign to get the angle. Make sure your calculator's in degree mode for all of these questions. You got to be in degree mode. If you have any questions on that, consult your owner's manual or email me or something. But you got to make sure our calculator's in degree mode. So if you're getting the wrong answers on these, even though you're doing it all right, ask. Okay. 36.4 is what we came up with on this particular question when I inverted the sign. Question 12 forces me to make my own triangle. Are you kidding me? Yes, folks, angle A, we use capital letters for angles and lowercase letters for sides. So angle A is 61. Side B, or side A, I can't talk, is 17 across from it. So you can see that in my picture. And then I've got side C, which is 10, which is across from angle C. So I set up my proportion, sine 61 over 17 equals sine C over 10. Cross multiply, got my fraction 0.514, inverted the sign, whammo, angle C is 31. And this one said, oh, this said nearest, oh, it was 30.96, and I rounded to the nearest tenth, and it still ended up a whole number. Okay, I thought I rounded to the wrong spot. And that's it for that one. Talk to you later. Bye.